is very
Mm-hmm.
glad that you are here. Mr. Srinivasan, you are here. And I really enthusiast towards you. You are a really robotics expert and enthusiast to the professionally you build the robots and learn about the robots. Uh, our audiences also hear about this. You are coming for the robotics enthusiasm, which is very really needed in the 2026 and next era also.
Mm-hmm.
Uh, we have a very good topic, which is like robotics without fear. Why you don't need to be smart to build robots. So this is a topic name, and I my first question, because everyone is having some journey, their own journey, dreams, uh, how they're facing their obstacles and learn something new. So, how is your journey towards the robotics from your school to from your professional career?
Mm-hmm. Yeah, I'm happy to join the podcast. So, t- yeah, just to give you some background, I've been interested in robotics since I was a kid. I still remember like early on when I was like in my seventh or eighth grade, I was building like a motor car, like putting a regular motor in a frame and then trying to drive it and failing miserably. But that's how I started. But I was also like really interested in robotics and AI and other things. So I still remember like when I was a kid I think in my ninth grade is when um, I started learning C programming, but I was programming basic programming language from I think like my fifth grade. So um, I was just playing with things. I remember writing pages and pages of basic program just to trying to do some kind of an artificial intelligence stuff, like some kind of an agent. And obviously, I failed at that too because after 10 pages of code, I was like, okay, this is the combinatorial options kind of blows up. So I kind of gave up. But so my background is like being being a programmer and always interested in robotics and programming, and that kind of gradually led me to into the field. So, um, so when I said that I was interested in programming and robotics from early on, you might have thought, oh yeah, sure, then you would have gotten into robotics right away. But that's not my story. Like I had like a lot of U-turns, a lot of kinks that I need to get across to actually get to the field. So, though I was interested in robotics, I didn't know how to actually get into the field. So, I did my undergrad, and then so my undergrad was in computer science, and then I had this program at Carnegie Mellon for robotics. So, I tried getting in, and then I actually didn't get into that quite program. So I kind of got into an embedded software engineering program. And then I worked worked on some projects, robotic projects there. Went back to industry, worked for a few years, and then got an opportunity to work at Robotic Institute again. And that's when my real robotic journey started, where things got serious and I was building like real robots. And it's been like more than like 10, 15 years now. I've been in the Robotic Institute.
That's amazing. So, like, it's really inspired, Bevel, because your journey, many things, your turn, and many more things you learn, fail, success, everything. Then after that, you learn. You never stop to learn. This is really very inspirable. Uh, uh, Today's kids in schools and colleges, people really uh, fear about the robotics because
Mhm.
they think that maths are required more. For that reason, they think that, oh my god, I can't do the equations. I can do the all the stuffs which is from the mathematical algebra. So
Mhm.
they stop their things in the
Mhm.
robotics. So how they people? start their robotics journey again
Hmm.
without any fear to maths?
Yeah. So, so the first thing, I mean, let's step back even further, like, and let's come back to math. But I think the one of the major things that kind of scares people when they think about robotics is they don't have any clue on what they have to learn. Like, what is robotics, right? Like, that's kind of like a fundamental question that gets into people's head. Is like, is it programming? Is it mechanical design, or is it like electronics? Like what I should learn? And so that's kind of like one of the main questions that people have in their heads, and when I talk to them, that's what they come up with. In fact, it's even harder to articulate like what the question is, right? They have a vague idea of when you say robotics, it's like, oh yeah, like humanoids walking and the field. That's what people think of robotics, but it's much more than that. So let me give you my definition of what robotics is. So in my head, robotics is more like it's a combination of different fields. It starts with programming, math, electronics, mechanical design, uh, primarily systems design, right? Like putting everything together to one coherent system. So you can call, I mean, automation, there is an overlap there with robotics. And so that's kind of like it's a mixture of everything, and it's kind of like everything coming together to form one unified system that has both intelligence and also capability to do actual work in the real world. So that's how I see robotics. So once we talk about that, then the next question is like, okay, I want to get into robotics. What are the things I need to learn? And then the first question is math, right? Like,
Yeah.
I don't know, or I'm not comfortable with math. Is it something that I can do? So um, to give some background, like I was not a math wizard or anything like that. I actually feared math equations when I was a kid, and it took me a long time to get more comfortable. And so the way I see it is each one has their own way of understanding math. And some people who are more inclined in math can just look at an equation and they can just say, "Oh yeah, I get it." They kind of like it clicks in their head instantly. For some, it's not like that. You have to go through it multiple passes, um, and then it slowly kind of like gets into your head. It doesn't mean that people who get it quickly understand it in a much deeper level than people who take more time. I've seen the opposite, where people who understand like the math equations right away, they have like a superficial understanding where if you, I mean, they know how what the equation says, how to use it, and maybe that's about it. But people who take much longer, they tend to have like a much deeper understanding of, okay, what does this really mean? How does it actually connect to real systems, and what is the real implication of a particular equation, right? So I mean, again, this is just, I'm generalizing it and kind of trivializing it quite a bit here, but uh, so what the main point here is like, it doesn't matter whether you take a long time to read math or equation versus like you can get it quickly. All it matters is you're persistent and stick with it. And then once you're ready to do that, there is an kind of like elegance to math, right? Like math is basically you can write a particular fact as one equation, or you can write a few paragraphs in English explaining what it is. So there is an elegance to it. So if you spend enough time with that, you will find the elegance and beauty in math. Again, I'm talking as I'm a mathematician, which I am not, and I still take time to read math equations to kind of like figure out what they do. But as I said, each one has their own style. So just what I would say to like people who are coming to this field is to take the time to figure out what your style is, and then be comfortable with that. So when you have to do something, if you are if you're going to take much longer to kind of assimilate the information, then plan for that. If you are quick with these stuff, then plan for that accordingly. So that's what I would recommend for people coming in new. And again, if you are not comfortable with math, you don't even have to do that in robotics. Like robotics is not just math, right? That's one part of the puzzle. There's a whole bunch of other things, right? Like I've seen roboticists who are really great at electronics. They can build like these great electronic systems, and but they're not like experts in math equations, right? They're just electronic stuff guys. I've seen people who are really great in mechanical design, and they can design like really complex mechanical systems. They can understand it inside out. And those people have seen them not being an expert in math as well. So math is one piece of the puzzle, and it's not like the most important thing that you need to do to get into robotics. It's good that if you can get it, but it's not like absolutely essential. And there is also different levels, right? Like when you get started, you're operating at a much lower level, and then as you go higher and higher, like becoming more and more of an expert, um, you might need more and more of these tools. And so depending on which area your expertise goes, you might have to choose the tools accordingly. So by tools, I mean either you're becoming whether you're an electronic expert or like a mechanical expert or a math wizard or a programmer. So uh, you get to choose what you want to become and where you want to specialize in.
I appreciate. Uh, what is the roadmap actually to get into the robotics? According to you, what should
Mhm.
learn for the beginner, intermediate, and advanced? What is the roadmap?
Yeah, so in my head, the way I see it is people who are getting started, they can just, I mean, you don't have to get into a robotic PhD straight away, right? That's not how things work. So you start with, if you're interested, just start with something really simple, like see if you can build a very simple robot, like a line follow robot. And there are a ton of these things online that you can just um, pick up some parts and then build a robot from scratch, and see whether you like it, right? That's kind of like where things start. And if you like that, then you can get a little more involved. So more involved means you can get into adding more intelligence to the robot. So add a sensor like a camera to it, and then try to add a Raspberry Pi or a Jetson module to that, and then try to make that work with that. So that'll be more involved, right? Like this is the line follow robot might be a very simple thing that you can put together in a weekend, and a Jetson module might take a little longer, a couple of weeks to a month. And if that interests you more, that'll also tell you whether you're interested in building the mechanical structure or configuring the electronics of the system or writing the software for it, or the whole systems side of things. So once you get that, then maybe you can decide on, okay, which area you want to specialize on. If you don't like it, just stop it off, move on to something else. But if you like it, then go on to another thing. So maybe pick up a course or something like that, and then just try to get into the details and make a little bit more progress in that particular area that you're interested in. And if the robotic bug still sticks with you, then just go ahead and maybe do a master's program, right? That's kind of like the next big step. Again, each of these steps, you increase your commitment, right? So if you're building a line follower, it's just like a weekend commitment. If you're building like a more involved robot using Raspberry Pi, it's like a couple of weeks of commitment. And if you're doing a course, then maybe a couple of months. If you're doing a master's, it's like a year to 2 years of commitment. And then if you're really, really a robotic fanatic, you can go and do a robotic PhD, like I did, and then go from there, right? And then there are also like other domains. Like once you don't have to like do a master's or a PhD, you can go into industry. There are a lot of opportunities out there where you don't even need a robotic degree. You just need like some degree, and then you can get into robotics domain and then do stuff there. So there is no like one prescription that fits all, but this is kind of like a general roadmap people can take to get from like a beginner or like a enthusiast to someone who can actually do stuff and become a roboticist.
Yes, definitely, and I really appreciate with the research and development is when if the going to a peak, very peak level, then
Mhm,
the robotics also be very high. Like you were saying, I took the point that you are saying the masters, you are little means little bit familiar with this with the robotics. When you are going to PhD level, you are totally familiar with the whole thing, what how the robotics work and how the robotics means what is the moment of the robotics.
mhm,
Uh, Today's world is full of AI, artificial intelligence,
mhm,
so everyone is fear that because when the robotics meet with the artificial intelligence, it can consume all the jobs. Because
mhm,
in industry, mechanical industry, we see that in Tesla and all the companies like this, they are literally use the robots to
mhm,
do the mechanical works, and instead
mhm,
of the people who don't know even who don't know the much of technical knowledge.
mhm.
So it's like what is the real problem in the real world, and how we can solve this, right?
Sure. Yeah, yeah. This is a question that a lot of people have in their minds, right? Like, okay, now AI is coming in, and then it's integrating with robotics. Oh my God, are we all going to lose jobs? What's going to happen? The fact is, no one really knows. That's kind of like, I mean, we can make predictions, but no one really knows in with certainty what would happen. But we can use history to kind of like project how things have happened in the past and get an understanding of what are the possibilities of things happening in the future, right? So that thing, the way I would look at it is like I would like to look at it in an optimistic way. There's a pessimistic way of looking at things, which is what most of the media is consumed about, and they're like, what is the most pessimistic way of looking at it? And Terminators is what they come up with. But there is an optimistic way of looking at things as well. And in my view, that optimistic way is like just going back to any major development, right? For example, let's go back to Industrial Revolution, right? When a lot of machines were brought in to do stuff. People had the fear that, oh, a lot of these machines coming in, we're all going to lose the jobs because the machines will do all the stuff. But what really happened is not that, right? Like what really happened is it opened up a lot more jobs. Obviously, not the jobs that people used to do, but a lot of new jobs, right? And a lot more people got into the workforce and got really paid, and their state of living actually improved compared to what it was before this industrial revolution happened, right? So that's kind of like the common trend. Like after before internet, people thought like, oh, all of these things like spreadsheet, people are doing like spreadsheets and document processing and things like that, right? And they thought, okay, when computers come in, all of these jobs would go away. But actually, there's a huge explosion of jobs came in, and a lot of people came into the workforce doing more white collar jobs. So it's kind of like a very common repeating pattern. When new disruption in technology happens, old jobs go away, that's for sure. There is no question about that. But actually, it doesn't go away completely. It transforms, right? So it transforms into something even better. So before industrial revolution, people are doing like this same thing over and over and over again, which caused a lot of health problems and mental issues and all those problems. But then after that, you don't have to do these repetitive jobs. You can just give it to the machines, and you get to do more creative stuff. You get to design stuff that the machines would build. And similar thing is going to happen with the AI when the robotics community and AI kind of like come together and build really capable robots. What really would happen is we wouldn't be doing these menial jobs anymore. We would be doing more kind of orchestration kind of stuff, right? And that's the role humans would move on. And obviously, there won't be a lot of orchestrators for the current set of jobs that we're doing. What will happen to the rest of the workforce? Well, we'll have more projects coming in, right? So just think of like any civilization, right? Like they always have or dreamed about a lot of things, but they don't have the manpower or the resources to do that. For example, we've been talking about flying cars. We have been talking about spaceships to go outside Earth, and we've been talking about these vacuum tube based navigation kind of things, right? Like the what is that? This loop thing. So this but we have not been able to do those things because we are limited on technology, we're limited on manpower and all those things. Once AI and robotics can take over that, then suddenly our capability becomes increases, right? Now we can do more projects that are interesting, and that's what's going to happen. So my kind of optimistic view here is like in the next couple of years, like let's say in the next um 5 to 10 years, maybe even like 3 to 5 years, a lot of these jobs would go away and get transformed into something more advanced or more orchestration based opportunities, and we would see a lot of new developments as well in the society. So that's my view of things, and I guess people should probably stick on to something optimistic than pessimistic at this point.
Yes, really, I agree, sure, and I appreciate with you. Uh,
Mhm.
uh, but if we think that the research and development area, what is
Mhm.
the best role in the research and development area? Because robotics having a different kinds of research and development areas. What is the best one? And the students, what should or professionals, what should they choose in the research development area, and how they help it?
I'm not sure if I understood your question fully, but let me try to address it. Correct me if I'm wrong. So you're just asking like how, which area should they choose in research? Is that
Yes, yes.
okay?
Which
Well, I don't think there is a common prescription for that, right? Like you cannot go to a doctor and say that, okay, I have illness, give me medicine. That's not how it works, right? So each one has their own kind of inclination. So another way of looking at it is like the way research works is you have this current body of knowledge, right? So you have um, like right now we know how these large language models work, and we know how robots work and how they interact. And there is this known set of things that okay, a large language models works this way, but then it has this limitation where if you run out of context window, then it won't remember the things that you talked about before, right? That's kind of like the common things we know, these is benefits and the shortcomings. That's the common body of knowledge that we know. What research does is it tries to poke at it. Tries to get to the very peripheral of the common knowledge or the common understanding, and then says, okay, is this really true? Can we try something else? Can we make it better, or can we make it break, or can we make it something else? And so it's basically pushing at the envelopes and may breaking it off, making the envelope larger. That's what research does. So that being said, you could think of it like when I said poking, you could think of it as like a needle, right? So you have this whole balloon of stuff, and then you're just poking at one point and kind of enlarging that there, which means that you can have infinite number of needles and poke anywhere you want it, right? And that's how you should look at the research surface area. There is a you could kind of like do research on any of these domains, any of these possibilities, and it basically depends on what is bugging the person who's interested in that, right? So research itself is a persistence game. It's not like, oh, I get in research, I'll find something and then I get out. It's never like a straightforward step. it's always like convoluted. You go in loops, you try something, it fails, you try something again, it fails again, you try something else, it fails again. So you keep trying and trying and trying, and that basically that trying would increase your expertise, and you become much more well versed in the particular domain. But also you try to know or understand what are the limitations of the system of the current body of knowledge, and then you figure out, okay, what are the things that kind of works or has some prospect of working, and then that is where you push the envelope. You say that, okay, maybe this is some idea that we should try out, and then that, if that is proves useful, then it opens up a new area, and then and the whole thing kind of the whole industry expands in that direction. So to do research, not everyone is kind of set up for that. What I mean by that is like anyone can do research, but to actually be a researcher, it takes a certain level of grit and a certain level of perseverance to kind of like go at it, because there's going to be a lot of failures, right? So to make that happen, if you don't have that grit and the perseverance, it's not going to happen. So to have that grit and perseverance, you need to have some kind of push within yourself. Like, okay, I need to figure out, like, this is something that is bugging me. I need to figure out what is going on here. Like, is that something there, right? Like, so each one, like I've seen a lot of PhD students, each of them have their own kind of like inquiry there. Like, okay, I'm really curious about this. Like, why is this like that? And that curiosity is what kind of takes them further. And that curiosity is what weathers them through all these failures, and eventually gets them to what they want to do. So when I said initially, like it depends on the prescription is unique for every patient, that's what I really meant. I meant like each one has their own kind of goals and their own like nagging sensation on that particular some particular idea, and that's what they should do their research on.
Yes, I appreciate, sir, about this, and uh, a really difference, something which is in our today's modern school, but
Mhm.
it is modern, but the methods are always old. You should go for the theories, take the marks, grades, and by that you can get the degree, but we lose our momentum in skills
Mhm.
almost. So
Mhm.
my question is that what is really required, skills or theoretical knowledge?
Well, if you choose either one, you'd fail, right? You have to need both. That's kind of the answer. And it's kind of the answer for anything in life, right? There is no black or white. There's always some kind of a spectrum. And you can decide to live on not in the middle, somewhere towards skills or somewhere towards the abstract thinking. You don't have to be like absolutely in the center, but if you just choose one, it doesn't work. Life doesn't work like that. You have to be cognizant of both, right? And I mean, and then these like the thing about skill and um, theory is not. If you go deeper, what you would realize is skills basically gives you the theory knowledge as well, and theory gives you the skill knowledge as well, like if you go deep into that, right? So I've seen people who started their career as machinists, where they didn't do any formal education. They All they did was they just took a piece of aluminum. They know what a lathe is, and then they know what it is, and then they were just chiseling with that, and then build these different models like for industry, right? And then slowly they kind of like learned, oh, I can take this and convert into like give it to a machine and do make it do my stuff for me like a CNC machine, right? And they learn to program that, and they come up with even nicer kind of machine parts. And I've seen like people who are really good at programming getting into it, not knowing exactly what to do, because they know the programming skill, but they don't know the theoretical knowledge of, okay, what are the parts that are missionable in a CNC? What are the things that you can actually get to with the tool? And these people who were machinists for so long basically develop the theory internally without even reading anything, just from the skill of machining things for so many years. They know, like, ah, you cannot do that, you just have to do it this way, and then they come up with these parts. So there is always this interplay between these skills, and like practical and theoretical skills, and you have to have both. And you don't have to like explicitly go towards one, you just go towards the one that attracts you, and whatever you do, become an expert in that. And then once you become an expert, then you slowly get to know the other things that are related to that. So one way I kind of tend to think about these things are, which is pretty important for the current generation of students, is um, the students nowadays try something out, and then they kind of like feel it harder, and they give up. And then they try something else, feel it harder, give up, and then they keep doing that. And in the I mean, this is human tendency, right? Like our human psyche is set up in a way that if you have to spend a little bit more energy, your whole biology is set up to kind of like avoid that. Because why do you want to spend energy? Because energy is costly, right? So that's how our own like biology is set up. So we try to avoid risky or hard things. That's how our human setup is. But in the past, people are able to go past that because that's the only thing they had, right? Like, let's say you are a hunter gatherer and you're trying to hunt, and running is harder. But then, if you want to find food, you have to run. There is no other way. So you kind of learn the skill. And once you become an expert there, you know, okay, this is not too bad. We can do that. And similar thing with tools. Like, okay, when they were first making tools, they probably hurt themselves making the tools. But then once you learned the skill and you understood what it is, then you know, oh, there is a benefit there. So they kind of taught it to the next generation. And that's how things have been up until the previous generation, where you have to go to school. It is painful to learn something new, but you know what? Like, if you learn it, it'll help later. But now, what's really happening is like we're not limited on the number of skills or the opportunities that are available, right? So, if you want to learn programming, well, there is an online course that you can pick up from the internet. If you want to learn to dance, yeah, there is another thing that you can pick it up. And if you want to learn music, yeah, sure, there's something else. You want to draw, there is something else. And then if you want to uh, paraglide, then there is also another thing that you can do that. So any skill that you can think about, there is pretty much like even free resources available to become an expert. It's a good thing, but it's kind of hurting this current generation, because what really happens is these kids try it out, they feel it's hard, and then they think, oh, this is not for me, maybe I should try something else. And that is a real big problem, because what really happens is they are giving things up even before they are picking up the skill or becoming expert. And what that means is they are actually going to lose a lot of, or like they're not going to become an expert in any of them. And that's not good for them or for the society, right? So there is, I mean, I think Indian parents still have this notion of, okay, they kind of push their kids to, okay, they cannot give up soon, they have to try, they have to force them to do things, right? So I think that kind of thing is really important at this point. Like um, both Indian and Chinese parents kind of like do that. Asian parents actually do that. And I think it's also coming to Western cultures as well, where parents are kind of seeing that, okay, this is a problem. Like, if they keep jumping to different things, they're not going to learn anything. And that is kind of an important skill that they have to learn.
Thank you so very much, sir. Like everyone, like in the student, while I am in my school,
Mhm.
literally all my friends also, we people are watching Iron Man first time, and we see that
Mhm.
the Tony Stark going to build a very good thing, which is like Iron Man short with the robotics. We really be
Mhm.
very proud and do something enthusiasm to build something, but that is not actually easy for us, right? At that time. So we really be down from that. No, no, this fit is not for us. We can't do this. So mostly we feel that yes, this kind of because of the less motivation, big motivation, but less effort. Because of this, we
Mhm.
really lose of that. Yes, thank you so much, sir.
Mhm.
And
Mhm.
so so this is all about this, and thank you so much for coming, sir. And
Mhm.
your I read about your some what like article about the
Mhm.
robotics. Yes, definitely, sir. So would you, if you send to me that link, and I can provide the total follow up for the students who
Mhm.
is really be wanted to learn and read about the robotics. That is
Mhm.
really when I stream that, I attach your link just below of my video, so that is really
Sure.
helpful for the students, to the students. Thank you
Okay,
so much
sounds
for
good. So,
coming.
yeah, I write about robotics in my Substack thing, so I can send you a link to that, so you can students can kind of subscribe and read about that.
Yes, thank you so much for,
Mhm.
and I
Mhm.
just now thank you for joining us, and I just